Okay, we're back with part 2 of section 4.2. Now we're getting into the theory-based approach. So going back to that formula for standard error of square root of pi times 1 minus pi over n. But now we're talking about the standard error statistics. So you often don't know what pi is, and so it's not like this formula in this formulation is really not useful. Like a formula with a number you don't know doesn't really help you much. But we can use p hat as a pretty good guess for pi, and then do the square root of p hat times 1 minus p hat all over n, and then square root. And that's called the standard error of the statistic. So calculate the standard error for this study. So do the formula. How does it compare to the standard deviation you found in number 7 and number 8? So make sure to calculate it using the formula, compare it to those two other numbers. So our confidence interval, this is the full formula for confidence interval with theory-based approach, is p hat, and then plus or minus, so confidence interval is two numbers, the upper and the lower, 2 times, and then this is the standard error formula. Okay. So this is the formula for 95% confidence interval because there's a 2 there. So for other confidence levels, you'll have a different number there. So for 99%, instead of 2, you'd have 2.576. For 90% confidence, you'd have 1.645. Okay. So in the theory-based inference applet, so we'll need a different applet, theory-based inference. Okay. So in the theory-based inference applet, specify the sample size n of 2,348. So 2,348. Okay. And then in the sample portion of 0.362, 0.362, and then and the count so if you click around it changes the count, and so then calculate. Okay, check the box for confidence interval, so confidence interval, and there we go. We get that number and that number. Okay. So report those numbers, and there. Is this theory-based confidence interval similar to the one you obtained using the 2 standard deviation method? That's a good question, so answer that. All right, validity conditions. This is really important. So the theory-based approach for finding confidence interval for pi, called the one sample z interval, so z corresponding to normal distribution, is considered valid if there's at least 10 observational units in each category. So if you have about at least 10 successes and 10 failures, 10 on one side and 10 on the other side, then you can assume normality. Okay? So we have in this situation, we have a very large sample size, and so we definitely have more than 10 in each category. So change the confidence level in the applet from 95 to 99%, and press the calculate. So then you'd go over here, change that to a 99, and calculate CI. Okay. Tell us, say how it compares. Okay, now let's look back at your class data. So here's where we get to look at our class data. So determine a theory-based confidence interval for the proportion of students at your school who currently live in a state different from where they were born. Do you think this interval is valid? Remember that your class might not have 10 saying yes and 10 saying no. So that's a very good question to ask. So you need to assume, to use the theory-based approach, you're assuming normality, and you should only assume a normality if you have 10 in each category. How does your interval compare to the interval you found from the GSS survey? So is it wider, narrower, shifted one way, shifted the other way? And then number 8, based on the characteristics of your sample and your school, does it make sense the two intervals compare as you described? So like use your common sense, your knowledge of the world. Why does it make sense that like the differences in your interval? Why do they make sense? Okay, that completes this section.